Welcome back to Mr. Vaughn's classroom, where math is made easy. Before we get started on today's video, I'd like to ask you to please hit the subscribe button, give this video a thumbs up, and engage with a comment below. In this video, we're looking at Unit 7 on quadratic equations, Lesson 23, using quadratic expressions in vertex form to solve problems. The learning goal in this lesson is to find the maximum or minimum value of a quadratic function. We have two learning targets in this lesson. When we're done with the practice problems, we'll come back and review these to ensure that you understand everything you need to before moving on to the next lesson. Learning target number 1 says I can find the maximum or minimum of a function by writing the quadratic expression that defines it in vertex form. Learning target number 2, when given a quadratic function in vertex form, I can explain why the vertex is a maximum or minimum. For glossary terms, we have maximum. A maximum of a function is a value of the function that is greater than or equal to all other values. The maximum of the graph of the function is the corresponding highest point on the graph. When we talk about the maximum, we are talking about the maximum y value. Next glossary term, minimum. A minimum of a function is a value of the function that is less than or equal to all the other values. The minimum of the graph of the function is the corresponding lowest point on the graph. When we speak of a minimum value, we are talking about the lowest y value. Next glossary term, vertex form of a quadratic expression. The vertex form of a quadratic expression in x is a times the quantity of x minus h squared plus k, where a, h, and k are constants, and a is not 0. In vertex form, the h is your x value for your vertex, and the k is your y value for the vertex. Now we can begin the practice problems for Unit 7, Lesson 23. In practice problem 1, they give us a graph of a quadratic function f of x, and they want us to find the minimum value of the function. The important thing to understand is that when they refer to a minimum value of a function, they are referencing the minimum y value. So we want to find the vertex, and we see that down here at the bottom of the parabola at the location -10, 0. This means the minimum y value equals 0. So that is the minimum value of the function. If you have any questions about how to find the minimum value of a function, please leave a comment below and I'll get back to you with any clarification that I can offer. Practice problem number 2. The graph that represents f of x equals the quantity of x plus 1 squared minus 4 has its vertex at -1, -4. Explain how we can tell from the expression that -4 is the minimum value of f rather than the maximum value. If you remember, we had said that if ax squared is positive, the graph opens upward and the vertex is a minimum. Well, if you look at this expression here, then we're going to have x squared we are going to have x times x, which gives us x squared. So ax squared here equals 1x squared, which means we have a positive a. This opens upward, so the vertex is the minimum. If you have any questions about how to determine whether a vertex is a maximum or a minimum, please leave a comment below and I will get back to you with any clarification that I can offer. Practice problem number 3 is the last practice problem in this lesson. Each expression here defines a quadratic function. Find the vertex of the graph of the function. Then state whether the vertex corresponds to the maximum or the minimum value of the function. So remember that in vertex form, we have a times the quantity of x minus h squared plus k. The vertex itself has the coordinate h, k, and the a term, if a is positive, then that means the parabola opens up, so the vertex is at the bottom and represents a minimum. If a is negative, then the parabola opens down, the vertex is at the top, and therefore represents a maximum. So, if we look at number 1, the vertex is going to be at the point 5, 6. A, we do not see a number, so it is understood to be 1. And since A is positive, this vertex represents the minimum. Number 2, the vertex is going to be at the coordinate -5, -1. The A term, we do not see a number in front of the parentheses, so it is understood to be 1. Again, since this is positive, the graph will open up. The vertex will be at the bottom of the parabola, so it represents the minimum. Number 3, the vertex is going to be at the location -3, -10. This time, A equals -2. Since A is negative, then it is going to open downward. The vertex will be at the top of the parabola and represents the maximum. Number 4, the vertex is going to be at the location 7, 11. The A term is 3, therefore it is positive. This parabola opens upward. The vertex is at the bottom, so it represents the minimum. Number 5, the vertex is going to be at the coordinate 2, -2. The A term, we do not see a number, but we do see a negative sign. That means A equals -1. Since A is negative, this parabola opens downward, and the vertex is at the top of the parabola, meaning it represents the maximum. And finally, number 6, the vertex would be at the location -1, 0. The A term, since we do not see a number in front of the parentheses, is understood to be 1. Since A is positive, this parabola opens upward. The vertex is at the bottom of the parabola and represents the minimum. I hope everything we've gone over in these practice problems has made sense to you. If you still have any questions about anything from the practice problems in this lesson, please feel free to leave a comment below, and I'll get back to you with any clarification that I can offer. Now, before we end this video, let's go back and review the learning targets for this lesson, just to make sure you understand everything you need to as you prepare to go into the last lesson of this curriculum. Now let's review the learning targets for lesson 23. Learning target number 1 says that you can find the maximum or minimum of a function by writing the quadratic expression that defines it in vertex form. This means two things. First, you understand how to write vertex form, and that the h is the x coordinate of your vertex, and the k is the y coordinate of your vertex. Now, once you find that vertex, then you need to be able to identify whether that is a maximum or a minimum. And in order to do that, you're going to look at the a term in your vertex form. You understand that if your a is positive, then that parabola is opening upward, which puts the vertex down at the bottom, making it a minimum. If your a term is negative, then you understand that means the parabola is opening downward, placing the vertex at the top of the parabola, making it a maximum. And learning target number 2 says that when you are given a quadratic function in vertex form, you can explain why the vertex is a maximum or a minimum. And this simply means you can explain that the vertex is the point at which the parabola changes direction. So either that vertex is at the bottom of the parabola, where it changes from decreasing to increasing, and because it is at the bottom, it has the lowest y value and is therefore the minimum. Or that vertex is at the top of the parabola, where it switches from increasing to decreasing, and since it's at the top of the parabola, it has the largest y value and is therefore the maximum. I hope that you feel comfortable making both of these statements. If you do, then you should be perfectly set up to move into the last lesson in this curriculum for Algebra 1. If you found this video helpful, then in the lower left of your screen, you should see another video that YouTube believes you will find helpful. In the bottom right of the screen, you should see the subscription button for this channel. Please support the channel by clicking that subscribe button, giving this video a thumbs up, engaging with a comment below, and I look forward to seeing you in the next video, which will be the last lesson in the Algebra 1 curriculum.